Alright, in this video we are going to look at graph traversal and graph implementation. So now let's take a look at this graph. In order to traverse this graph, let's take a look. So we have two ways to traverse it. One way is called depth first. So let's take a look at the depth first. Because graph isn't linear, so we have to figure out exactly how to visit every vertex here. So for depth first, if we start with A, we're going to go all the way, say like how about I'll start with A, then A is connected with B, and B is connected with C. So you see I'm going all the way B and C and marking it. As I'm visiting every vertex, I'm going to mark them as visited. This is important, otherwise you don't know if you have visited this one or not because it's not linear. Okay, and go it's depth first, so let's keep on going. Then D, then keep on going. From D you can go H or G. I'm going to randomly pick one, either one's fine. So I'm going to pick G here. So I'm going to pick G and mark it, and G go with F and mark it, and F go with A, because now you see why we have to mark it. This way when we see A is marked, we're not going to visit it. Alright, so this is depth first. So you go all the way, starting from A, go all the way to the end, nowhere to go because A is already visited. Then you backtrack. Okay, so now you backtrack. So the first one to backtrack will be look at F. Say, because F is the last one, say F, are you connected with anyone we haven't visited yet? The answer is no. Then you look at G. So G, are you connected with anyone we haven't visited yet? The answer is yes. E, we haven't visited yet. So we visit E, and then you look at D, so you backtrack it. D, and D has H, so we visit H. Then you backtrack to C. C, all the adjacent ones already visited. Then you look at B, already visited. Then you look at A. Then there's an I there. Now everybody got visited. So let's call the depth first. Depth first, you go all the way to the end, then you backtrack. So you can imagine it's a last in, first out operation. The last visited vertex that go this steps will get revisited first. Alright, so that's depth first traverse. As you can imagine, if you're trying to implement this logic, you could use a stack to implement, like the last in will get revisited first, the adjacent vertex. Alright, so that's depth first traverse. And now let's take a look at the second one. It's called breadth first traverse. Let's see. For breadth first traverse, let's start with A again. Let's start with A, and you're trying to visit every neighbor of A first. That's breadth with traverse. So we're going to visit A and all the neighbors. So mark them as you're visiting I, B, and all the neighbors. It's breadth first, F, and so all the neighbors of A got visited. That's 1, 2, 3, 3 neighbors. And now let's take a look at I. So it's in order. So I doesn't have anyone adjacent to it that's not visited yet. So we look at B. And B has A, that's already there. Then C, we mark it. Then E, we mark it. Okay, now it's time to visit F's neighbor. So F's neighbor got A already marked, then G. So we put G there. Then it's time to visit C's neighbor. C's neighbor got B and E already visited. Now it's D. So we put D there. Now it's time to visit E's neighbor. Everybody's already visited, so don't have anyone. So then visit G's neighbor. O visited, then visit D's neighbor, then H. So you see, it's breadth first traverse. That means you visit all the neighbors first, then you do a first in, first out. So then you say I, well, how about your neighbor? Then B, how about your neighbors? So as you can see, if you need a secondary data structure to implement this traverse ordering, you can use a queue. You can picture, you can use a queue to do this, the first in, first out order. So that's breadth first traverse. We look at how to traverse a graph, and now let's take a look at how to implement the graph. Adjacency list is one easy way to implement a graph. So let's take a look. So A, this is a graph, and it's a directed graph. So if I pick on W, let's say W is adjacent to S. From W you can go to S. From W you can go to Y. That's a two edge that's connected with W. It's a directed graph. And how do we implement this logic? We're using an array of linked list. It's called adjacency list. Array of linked list. So pick one of them. Like, let's take a look at P. This vertex P. Vertex P is connected with W and R. So you have R and W here. So we use a linked list to model to model the adjacent nodes here. And let's take a look at Q. Let's see, where is Q? And Q is only connected with X, so you get the idea. And for example, if you see W is connected with S and Y. So you see, this is a very easy implementation to implement a graph by using adjacency list. Adjacency list is just an array of linked list to model the connections between vertices, and to see if there's a direct edge or if there's a path between one node and another node. So I'll leave this one as an exercise for you guys to model this adjacency list. Thank you.